Okay, class. So in the last section, we found that there is a relationship between a central angle and the arc that it creates. On today's agenda, we are going to find the real length of an arc using a ratio, meaning we're going to find the length not in degrees, but in actual length. And we're going to do work on this page and answer these questions to do so. Then we are going to learn to put our answers in terms of pi, which is pretty simple. After you work out a couple of problems, we're going to work on this page here to help us do that. After we're done with that, we are going to find the circumference of a circle without the radius. In order to find the circumference, you need the radius to plug into the formula. But we're going to find a way to do it without the radius. And then finally, we're going to use algebra to find the radius from a given circumference. So sometimes they give you the circumference, and they want to ask you what the radius is. So you're going to need to use some algebra in order to do that. And we're going to work on these pages to do that. And once we're done with this page and these exercises, we're going to have a quiz. Okay? So let's get started. Here I have a circle, and it's called circle Q. And circle Q has a radius of 1.60 inches. Remember that the radius is the distance from the center of the circle to the circumference of the circle, to the edge. And remember that the circumference, boys and girls, is the distance around the circle. So let's pretend for a second that you were an ant and that this was a racetrack. And I asked you, well, how many inches would the ant have to run around this racetrack? Well, the circumference would be the answer to that. The circumference would be the answer to that. So what is the circumference? How do I find a circumference? What's the formula for the circumference? Well, the circumference of a circle is equal to 2 times pi times the radius. And you'll see this formula on your reference sheet a lot of times, and it'll just say C is equal to 2 pi r for short. C stands for the circumference, and the circumference is equal to 2 times pi times the radius of the circle. So the circumference of this circle here, of a circle that has a radius of 1.60 inches, would be found using this formula here. The circumference is equal to 2 times pi, which is 3.14. Pi is always 3.14, times the radius. And the radius of this circle is 1.60 inches. So the radius is 1.60 inches. So the circumference is equal to, when I multiply all these three things together, 10.04. So the distance around this track, if I was an ant, let's just say, would be 10.04 inches. Okay? That would be the distance for my track, around my track. Now, 10.04, that's such a small decimal number there that I'm just going to round out the distance of my track. I'm going to round it out to 10 inches. Okay? I want to round it out to 10 inches because we're going to be actually analyzing the distance around this track. And 0.04 is actually hard for us to measure. So I want you to notice here that I took the circumference of the circle and I divided it into equal portions of 1 inch. Meaning I took the 10 inches and I divided them into little inches. So this is 1 inch, 2 inches, 3, 4, and 5. And that makes sense because if my whole circle is 10 inches and this is half of my circle, if this is a semicircle, well then I should have 5 inches up here and then 5 inches down there. And if you notice, they're all pretty equally spaced out. So I got 1, 2, 3, 4, 5 in this half, 6, 7, 8, 9, and 10. So I've taken my circumference of 10 inches and I've divided it into 1 inch parts. Okay? Now, let's see what I do here with the circle. Now notice that I took my circle and I took my 1 inch arcs and I made angles with them. I made central angles with them. Okay, so now I've cut up my circle into 10 different angles here. And if you remember, a circle has 360 degrees. Well, if I take those 360 degrees and I divide it by 10, I get 36 degrees. Which means that if I take the entire 360 degrees on the outside of my circumference and divide it by the 10 arcs that I have, each arc is going to be 36 degrees. If I take the 360 degrees that comes from all the angles inside, and I divide it by all the 10 angles that I have, that means each central angle is also going to be 36 degrees. So all I've done here is divided my arcs into 10 angles, and I've figured out that each one of them measures 36 degrees. And of course, the measure of a central angle is equal to the arc that it creates, and the measure of an arc is congruent to the measure of a central angle. Well, now, let's get to the business of actually finding out how big an arc actually is. So let's take a look at this circle here, right? I have my same circle, and I'm interested in finding out what is the measure of arc AC, okay? I think we can look at arc AC, and I know that the central angle is 36 and 36, so the measure of arc AC would be 72 degrees. 36 times 2 would be 72 degrees. But the real question is not how many degrees is arc AC, but actually how long is it? If you were a track star running on this track, or let's just say an ant, because this is a small track, let's say the question is how many inches would the ant have to run from point A to point C? Well, looking here at the circle where I've, put the numbers for you, it's pretty easy to see that it's going to be 1 inch from here to here and 1 inch from there to there. So it's going to be 2 inches. It's 2 inches. But we need to be able to use ratios in the future to answer these questions. So let's take a look here. How big is my arc AC? Well, first things first, my arc is actually 72 degrees. It's 72 degrees long. But it's 72 degrees out of a total of 360 degrees. So there's my ratio. When you want to calculate your ratio, it's how many degrees always out of 360 degrees. So really what this is going to give me is, it's going to give me a percentage. I don't know what the percentage is, but it's going to give me a percentage. I know that I have 72 degrees out of a total of 360 degrees, and that's my ratio. But the question is, a ratio out of what? How long is the actual length of my track? Well, if you remember, we said that it's 10 inches. So really it's this ratio out of 10 inches. So when I divide 72 by 360, that's going to give me 0.2, which if you remember is 20%. So really what I'm talking about here is 20% of my circle. Well, 20% of what? 20% out of the 10 inches. And when I multiply these two together, it's going to give me 2 inches. So as we look here, we can see that yes, it measures 2 inches, 1 inch and 2 inch. But my ratio helps me get the same answer. 72 divided by 360 times the entire circumference tells me that I have 2 inches. And we can see that here. Let's take a look at another circle. Again, I have my same circle, and now my question is, how big is arc AD? How big is it arc from A to D? How big is that? Well, how many degrees is that? It's going to be 36 degrees, 36 degrees, and 36 degrees. 36 degrees. I add all those 36s together, and what I end up getting is 108 degrees. But it's 108 degrees out of how many? Out of 360 degrees. So that helps me set up my ratio. Now, this ratio is coming out of what? It's coming out of the entire circle. So it's going to be 108 degrees out of 360 times 10 inches. It's times 10 inches. So it's my ratio out of the entire 10 inches. Well, when I do a little math, and I type in my calculator, 108 divided by 360, that gives me 0.3 out of my 10 inches. And when I multiply 0.3 times 10, that's going to give me 3 inches. And we can see here that this is correct. This is 1 inch, 2 inch, and 3 inches. Now let's take a look at some other problems. Let's take a look at this first circle here. Here I have a circle with a central angle of 50 degrees. I have a radius of 5 centimeters. So if this central angle is 50 degrees, I also know that this arc here is also going to be 50 degrees. But what I really need to know is, what is the measure of arc AB? How big is arc AB? Well, I know it's 50 degrees, but that's not really the length of it. That's just 50 degrees out of the circle. In order for me to know what that 50 degrees is coming from, it would be good to know what the entire circumference of the circle is. It'd be good to know what the entire circumference of the circle is. So the first question you always want to ask yourself is, how big is your circle? How big is your circle? Do I really know how big my circle is here? No, I know that it has 360 degrees, but I don't know how big it is. So the first thing you always want to know is your circumference. And if you remember, we said the formula for the circumference is 2 times pi times r. The circumference is equal to 2 times pi times the radius. Well, in this circle here, what's the radius? It's 5 inches. So we're going to find the circumference using 2 times pi times r. So 2 times pi, which is 3.14, times 5, gives me 31.4 centimeters. That means that the circumference of my entire circle is 31.4 centimeters. Well, now that I know that the circumference is 31.4 centimeters, now I can actually figure out what the measure of arc AB is. But you want to remember that your arc is part of the circle. It's a ratio. So really, it's going to be 50 degrees out of how many? Out of 360. That's my ratio right there. But it's a ratio out of what? Well, it's a ratio out of my circumference. So it's going to be 50 out of 360 times the circumference. Well, this ratio is going to give me a decimal, and I'm going to multiply that decimal times 31.4. So I'm going to divide 50 out of 360, which gives me this, times my circumference. And when I do that, I get 4.36 centimeters. That means that 50 degrees out of my circle is really equivalent to 4.36 centimeters from the circumference. So it's 50 divided by 360 times the entire circumference of your circle. Let's see if you guys can work some out on your own. Here I have a circle. The radius is 7 centimeters. The central angle is 60 degrees, which means that this arc here is also going to be 60 degrees. But what is the measure of arc CD? Take a minute to figure that out. Okay? Well, I hope that the first thing you remembered is to ask yourself is, how big is your circle? And in order for you to do that, you need to know what your circumference is. Remember that your circumference is equal to 2 times pi times the radius, which in this instance would be 2 times 3.14 times a radius of 7. So my circumference is equal to 43.96 centimeters. So if you were an ant on a circle that has a radius of 7 centimeters, it would take you 43.96 centimeters to go the entire way around. So remember that your arc is actually a part of the circle. It's a ratio of the circle. So I have 60 degrees out of 360 degrees times my entire circumference, and my answer should be 7.34 centimeters. So the measure of arc CD is 60 degrees, but in actuality it's 7.3 centimeters long. Let's take a look at another question. Let's say here we have a circle with a radius of 8 centimeters, and we have a central angle of 100 degrees, and they want to know what is the measure of arc EF. Well, again, I know this is going to be 100 degrees as well. And by now, I hope you figured out it's 100 degrees out of how many? Out of 360 degrees. But I also need to know how big my circle is. I need to know what is the actual size of my circle. Well, in order to do that, I need to know what the circumference is. The circumference is 2 times pi times r, so it's 2 times pi times 8, which gives me 50.24, which means that the entire distance around this track is 50.24 centimeters. And now I want to know, well, how big is that 100 degrees from here to here? Well, remember, your ratio is 100 out of 360. That's how big your arc is. It's 100 degrees out of 360. So you're going to multiply it times your circumference. That's going to give you 13.96.